there. Yes, you can move on to the storage spaces, Kirby.
Okay, so we're going to data management. Okay, so we've just talked about all of these different storage elements and the fact that we have petabytes of data, and how you access them and how you get directory names. But quite honestly, if you were manually trying to access all of that data, or even some small fraction of petabytes of data, it is going to be really inefficient. Just people manually doing that, we don't function properly. In fact, it's one of the reasons that we invented computers in the first place, is to do tasks like that for us. So questions that we want to answer: what are the data tools and software for DUNE right now? How are the different software versions handled? And what are some of the best data management practices? How do we learn how to access data from the DUNE data catalog? And then at the end, if we have time, I'll talk about some of the roles of tools like UPS, MRB, and CVMFS. So as I mentioned, DUNE data is stored around the world in storage elements that are not always organized in a way that they can be easily inspected, right? You don't necessarily have access from the DUNE GPVMs to any of the storage elements at CERN, right? But the question is, how can I find out what data might be available at CERN from ProtoDune, or maybe it's available in the UK or in Spain or Canada or India, wherever it might be? Well, to accomplish that, originally, that same problem came up for the Tevatron experiments, D0 and CDF, and a solution was created, the sequential access via metadata. It's a data catalog created at Fermilab, and it's actually used by a lot of the intensity frontier experiments. And the idea is that the objects that are stored within SAM are information about individual files, and then collections of files called data sets. The data files themselves are not stored in SAM, but instead the metadata and their physical locations are. And then via that metadata, you can search for and locate collections of files. So again, SAM doesn't, the SAM database doesn't actually know what's in, doesn't have the actual bytes inside the file itself. It just has descriptions of what is in there. So when, the day when data was taken, what processing was done to it, how large the file is, how many events are in the file, things like that. Not the actual data itself, but the metadata. SAM also provides a mechanism for initiating and tracking file delivery through projects. I will go over projects in a little bit. How to access data files that have been defined within the DUNE data catalog. Execute some commands after logging into an interactive node and then sourcing the main DUNE setups. And so we can start to see, how can I get a list of files out of the catalog? How can I get more information about a file or a data set out of the catalog? And go from there. So again, SAM is that file catalog, keeps track of all the files, their metadatas, and their physical locations. We have another data management tool that is Ruscio. Ruscio is the next generation data replica service. It is part of DUNE's new distributed data management, and it is currently being deployed. It has two functions. The first one is a rule-based system to get files to Ruscio storage elements, RSEs, around the world and keep them there for the lifetime of a file. So say we have a simulation file that comes back from a grid job, production job, lands on the Scratch Dcache at Fermilab, and Ruscio says, hey, I have a rule about that file based upon the metadata that I have about that file, and I'm supposed to put it on permanent tape storage at Fermilab, and then I'm also to make a copy of that and store it someplace else in the world, say at in France at IN2P3. Ruscio does that. It takes and makes a copy of the file onto tapeback Dcache, and then also onto a Ruscio storage element over in France or wherever you have an RSE. The other role is to return the nearest replica of any data file for use, either in interactive or batch file use. And it's expected that DUNE users will not regularly use direct Ruscio commands, but other wrappers will call them indirectly. So as the date of this December 2021 tutorial, the Ruscio client is not yet installed as part of the standard DUNE client software. And most DUNE users aren't able to use it, but right now we are having it manage all of our data and move things around. And then when it puts it to a new location, we are then parsing that location and putting it back into the SAM file catalog so we have that additional location. I did mention lifetime of a file. We're putting that in for every file that is in Ruscio. Our raw data has an infinite lifetime, but things like simulation or reconstructed data, we expect those to have a lifetime of about 2 years. And eventually Ruscio will go through and actually delete all of those files and clean up so that we can reuse that, either that tape or that disk or what have you, so that we won't have what's called dark data files that are sitting around that no one is ever going to access again, but are still just consuming disk space or tape space. So those are the two main things that we're using as data management right now. I'm not going to talk a whole lot about Ruscio anymore. I'm mostly going to focus on SAM, but in general, do people have questions about the kind of the general purpose of SAM and Ruscio at this time? Okay, let's dig into SAM. So it was designed for large-scale data processing to make sure that it was done completely and accurately. So, and there are a bunch of features, kind of the like 6 primary features is to make sure that even if there is a transfer failure or a processing failure, we know about the files that have been processed or have not been processed, and that we've got full coverage of taking a data set, moving it and out onto the grid to be processed, and then coming back and putting that back into storage. So description of the contents of data collections to allow later retrieval, this is basically metadata. Tracking of object and collection parentage, so that again, you understand where a file was, kind of where it came from, and then what it was used to produce later on. Grouping of objects into larger data sets based upon their characteristics. So what time, what run number maybe is one, what detector they were produced from, or if it's simulation, what was the Genie version that was used, or what was the calibration that was used, all things like that. Stores physical locations, but then also when we start thinking about projects and taking all of that data and putting it through a workflow, we want to track the processing of collections. We want to have methods for delivering and tracking those collections in multi-processing jobs, and then preservation of data about that processing and storage. So the first 3 goals are content and characteristics, while the last 3 are more about data storage and processing tools. There are some specifics that I should go talk about. Within SAM, there is always metadata associated with a file name, right? And every file name must be unique in the system. So you cannot have 2 files that are called, run 1234.root. If you have another file that, that was run 1234.root that you tried to register in SAM, you would get an error and you would be prevented from doing that. This means that you can have multiple copies or multiple copies in the storage elements, so multiple locations in SAM, but only one file associated with one set of metadata. The next specific metadata for a file can include locations, but it doesn't have to. A file can have no location at all or many, right? So if a file is transient and we didn't permanently store it, but we still need it for parentage information, we can register it and then it doesn't have a location. SAM doesn't move files, it just provides location information. When you want to move something, you're going to be using IFDH or extd. And temporary locations, such as decast scratch or on a grid worker node, you don't want to report back to SAM. So files are stored on disk and tape. They're expected to have appropriate file size and checksums. Checksum, basically the idea is it's kind of a hash of the contents of the file. And if a bit is flipped or there's an error in a transfer, your checksum will come out differently. So the file size and the checksum allow you to know that you have a good and robust copy of the same file everywhere throughout all of the different locations. As I said, files can have parents and children. Yeah, effectively birth certificates that can tell you how they were made. We'll go into that a little bit more in detail. But just keep in mind that idea that you do have a lineage of all of the files that are registered in SAM. Some of them, the lineage is, this is the original file. It came straight out of the DAQ, so it has no parents, but then you would have all of the children from that file. Within the metadata, I should say that SAM supports several types of data description fields. So there are values, and these are standard across all implementations, things like run type, file size, and those are things that have set values in them. So there are only a limited number of run types that are available. If you want to add a new type of a new run type, then an admin for SAM has to add that in. But then there are also parameters that are defined by the experiment. So we have like Monte Carlo, the Genie version that we use to generate simulation. That is a parameter within SAM, and that's defined by DUNE. This is numbering is supposed to be 8 and 9. So I messed that up when I was editing this. But I'm going to skip the idea of a spill or luminosity block.
Yeah.
But let's not worry about it. I will say SAM currently does not have a means of easily determine in which file a given event is in. It only has the first event and the last event, but nothing is required to be sequential inside of that. And you can skip events, but it just is going to list the first one and the last one, and that's it. So I think it actually might be useful for me to skip down a little bit and look at an example of metadata from DUNE. So this output that you see right here is metadata for a specific file. It is this file right here. And all of this metadata is registered in the file catalog with that specific file name. So again, file names are unique. So there is only one file with this name in it in the catalog. And so the metadata that is listed below that is again unique and matched to that one specifically. We have things like a file ID. This is, the 7,352,771st file to be registered within the DUNE SAM file catalog. It has a creation date, an update date. Heidi was the person that updated this file. You see a file size, a checksum, status, file type. It is a detector file. So this came out of NPO4. It's raw data. The NPO4 raw data, but it is now reconstructed. I say that because here's the run number, the subrun, but then and all of the subsequent processing that went on after that. You can see things like there's an event count, a first event, a last event, start time, end time, data stream. But then we also have things like looking at the parents right here. So this was the raw data that was processed to produce this event, and the run number, and is this fake data? So this gives you some idea of what are the possible metadata that you could record and associate with a file. So we're now going to kind of go back and talk about data sets and projects, but I'll pause for a moment, ask if folks understand metadata or have any questions. The next bit is a little bit interesting and sometimes and important to emphasize. Right now, a SAM data set is not a fixed list of files. but a data set is actually a query against the SAM database. So a nice example is right here. I would like to see all of the data that's in the tier reconstructed, everything from run number 2001 and version 10, right? The thing is that's a data set. The list of files that matches that query today doesn't necessarily mean that it is the exact same list of files that will match that query a month from now. The reason is it is a dynamic data set. SAM goes in, and every time you ask for a data set, SAM asks how many files match this criteria, this query. If somebody found a missing file from run 2001, reconstructed it with version 10, the data set will grow. Now you can take a snapshot of a data set, and that is in fact a fixed file, set of files. It's the exact files in the data set when the snapshot was made. This is different. So note, most other data catalogs assume a data set is a fixed list of files. That is a snapshot in SAM. A data set is a query. A snapshot is a list of files. There's also a concept called projects. And this is the tracking mechanism that SAM uses when you have a workflow, something you want to do. Maybe you want to reconstruct all of the hits, or maybe you want to reconstruct tracks, or maybe you want to generate an n tuple. And you have a data set, or you have a snapshot, and you say, okay, I want that to be processed with this specific workflow. SAM will provide you with a project that will grab all of those files and then track them as they get delivered to all of your grid processing jobs. So your job is to choose a data set and then ask the processing system to launch a project for that data set. It effectively is a processing campaign against a data set and is owned by the SAM system. At the launch, you get a snapshot, and then the files in that snapshot are delivered to a set of consumers. Consumers here being grid worker jobs. And then the project maintains an internal record of the status of all of those files and whether or not they've been consumed. The idea being that SAM won't deliver the same file twice, right? It will only deliver a file to one worker node, so you won't get duplicate files. But then you can also go back and look and see, hey, which of my files were delivered and they were successfully delivered. Because if your grid job reports back a failure, it can report that failure back to SAM, and then you will know, these are the files that weren't successfully processed. They ended up going to a grid node that was bad and it failed, and so now I need to process it again. So you can actually look at all of the running projects. I'll click on this link, which is dangerous because I haven't clicked on it before. I may need to sign now. Here we go. So here's an example of project names. And you can get files in the snapshot, how many files have been seen, how many processes, how many things are waiting. But you can see, like right here, there's a pre-stage command, which is actually a Samweb command that is used to make sure that all of the data from a data set is located on disk ahead of time before you actually submit the processing job itself. But now is processing the prod 4A 1 GeV Monte Carlo. And there are 7,700 files in that data set, and there are 1,000 files seen, and there are 5 processes and 2 waiting. So welcome, Jake. We'll go back to the tutorial. I'm going to skip information for admins, maybe useful if you want to go back and look at it. But for now, let's just get down to doing some fun things with Samweb. Samweb client is the command line and Python API that allows queries of the SAM metadata. And it also allows you to create data sets and tools to track and deliver information to batch jobs. I mentioned, you need to log in, and then you need to set up the DUNE software. So first you access CDMFS, set that up in your environment. Then you set up DUNE TPC, software, probably you do need to set up the Fermilab security to get yourself a grid certificate. And then Samweb allows you to select on a lot of parameters, and all of that is documented here through the user's guide, query dimension syntax, some useful proto-DUNE Samweb parameters, and then also a list of official data sets. I should mention, you don't want to be creating data sets kind of just willy-nilly. The data set already has to exist. We should all use that same data set. One of the reasons is for all accessing the same data. It will always going through the same data set definition. It will stay staged on disk, and no one will have to worry about pre-staging it. But also at the same time, it is a consistent list of files, so that if you say, hey, I process this data set from the official data set definitions, and you want to compare that to someone else's results, you already know that you're processing the same files. Okay, so I've already gone over the example of metadata from DUNE. And so now we're going to dig in a little bit to find out what it looks like when we try and pull information out of the SAM file catalog. So that file that we started out with, that we have the metadata printed from, there are two things that are straightforward. One is, let's find out what the children of this file are, and you can use this command. So you've already set up DUNE TPC in your environment. You've set up your grid certificates. You'd issue a Samweb command, and then the second option is what you actually want to do. So in this case, it's give me file lineage, specifically the children, and then the file name. And then the output that you get from that right now is just one file, because there's only one direct file coming from this initial one. But then we also have the question of, oh, and I messed this up. You could do it the other way around. I could take this file right here and say, what are the parents of that file? Which there could be two. You could have two input files and one output file of a workflow. This right here was supposed to be the parameter on this one, and I messed up the parsing of that when I was writing this web page. But anyways, so if you do Samweb file lineage parents and this file name right here as the final parameter on that command, you would get back that original raw file. So that's an interesting thing that you can do once you already know a file name. Is you can look and see, okay, what are the parents, what are the children's, and you can go up and down that lineage all that you want to understand where the files got generated from, and then also look up the metadata for those files as well. So the next question is how about if we want to locate that file? Well, we can do Samweb locate. And if we took that raw file, that raw DAQ file, we actually notice the output looks like this. There are 4 locations. One of them is a Ruscio location. It is within this container for Ruscio. It is proto-DUNE single phase data. But then also we know that it is located on CERN EOS, which is a disk at CERN. It's on Castor, which is tape storage at CERN as well. And then NSTOR, specifically tape back storage at Fermilab. And it's also located on that disk right there. But those locations right there actually aren't convenient necessarily for how we want to process something. Instead, we want to get a URI or URL. So you can do Samweb get file access URL and then the file name. And instead of using the raw data file, we've actually put in the process data file. And now you get a grid FTP location for the EOS one, and then it's tape storage. You notice that Castor is not a possibility. The tape storage at CERN, you can't go directly through to it. You have to go to EOS, and there you have to manually stage from tape. And you also notice the Ruscio container, it is just it's not a physical location, it's a meta location. And so that Ruscio container doesn't actually provide you with a file access URL. I should going back to Ruscio a little bit, those location, that container location, that's one of those things when I talked about the rules that would be applied to distribute a file to multiple locations, that container is what's going on here of how do we know, oh, all the files that are located within this container, they're going to be distributed around the world. Note, this is grid FTP access. Instead, normally you kind of want to go through extra-D. That's the thing that I would suggest most strongly. So now we can take that command, and instead of just saying that give me the default access, we can say, give me the schema for root. And now all of a sudden you see that you get a root, an extra-D URI, and you can use that with your extra-DFS commands or extra-DCP commands and use that. You do now get an additional Castor one, but I would advise against using Castor because it's tape and what have you. So you can filter locations. So here I've shown what if you just want to look for NSTOR, or if you want to look for Castor or Cernios, you can add on a location that goes NSTOR like that. And then you only get the NSTOR location out of SAM. Okay. Now, what if I want to, as opposed to, so the first things that I was talking about there was all about getting information about a file. Now that I've already got the file name, or if I've found another a child file from that and I want to get information about that and access. But now the question is what if I want to query the SAM catalog for files based upon some criteria that I want? So to show you how that's done, we can look at this command right here. I've said, Samweb, what I want you to do for me is I want you to list all of the files in the catalog that meet these criteria. The run number is 5758. The run type is Proto-DUNE single phase, and the data tier is raw data. And what SAM does is it goes in, it takes those query parameters, looks in the catalog, and then produces a list. So this is a truncated list, but you'll end up getting a list like this. What if you want to add something on top of that? I want to change. I don't want the raw data. Instead, I want the fully reconstructed, and I want specific versions of the reconstruction. So right now, in general, we're working with DUNE TPC, I think it's 92202. But what if we wanted to look and see, this is old data from Proto-DUNE single phase, and we want to look at version 708.0003, but then also another patch release, v708.0004. So now I can do a comma separated list inside of parentheses, and I will get all of the files from that. And then again, a truncated list. But in general, that's how you can get a list like that. To get some more recent ones, you would go with run 5141, Proto-DUNE single phase, fully reconstructed, but I want to look for DUNE campaign, Proto-DUNE single phase prod 4, and now I get a much more recent, a file that if I look at this date right here, was created in March, on March 18th of 2021, as opposed to these up here that were created back in November of 2018. I should also mention that to see the total number of files that match a certain query, all you do is you add -- summary option after Samweb list files. And instead of getting the entire list, you'll get just a summary of how many files, how much data, and how many events are contained within that query that you have. Oh, and there is an example of that, but it's messed up somehow. But you can type that in. And in fact, I'm going to cut and paste and show you what that looks like real quick. I'm doing this real time, so we'll see what happens.
In the meantime, I just want to say that this website is going to stay, so you can we'll update it and correct it for further references, so you can have time to do the exercises and still contact us later on. Yeah. So I think you're almost done, Kirby, and then we could perhaps have a bit of a break and distributing the quiz, and then go over the quiz quickly, and then Ken is going to take over. That's great.
Sounds good. Yep. That
Larry, you're
query
a
is
great
taking a little
boss.
while. Yes. Well, apparently there are no files. So that's why
full
you always check.
reconstruction. Okay,
That's
so
okay.
maybe make a data stream physics. Maybe we didn't do any cosmics. I have a feeling that the high voltage value may not have been carried over.
There we go.
Yeah, that's a bug.
Okay.
Let's see what it does. If it takes this long, it generally means it's doing something. Yeah, there it is.
There we go.
Okay.
So I now know that if I took this query right here and created a data set, I would end up getting 52,960 files. The event count would be on the order of 7 million. And oh, by the way, this is how many bytes that would be. So if I look, that's megabytes. No, that's not what I wanted to do.
It's 243, I think, total.
243
43 terabytes.
Terabytes. Thing to remember, 243 terabytes is a whole lot of data. You might not want to try and stage all of that data. In fact, I would definitely advise you not to do that. There is, as far as I know, there isn't a human readable option on this. So
we destroy our lives to pack the numbers per group of 3 and see which ones is it tera, peta, or giga. Okay, thanks.
Yep, exactly. But if we go back, here, the thing you can do is you can create a definition based upon that. And note that the username appears in the definition. If you're doing this as for your own sake of creating a data set definition, and I'm going to go back and edit this so that no one creates this data set definition and then tries to process it. You should put your own username. If you end up in the production team, then that changes a little bit. But for any data set that you're going to create and define, in general, put your username in it. One, you can track the data sets that you've created, but also so that other people know who to talk to about a data set if they happen to come across it. I'll move quickly. SAM validate data set, locality, and a file. If you put the file in here, you can find out whether or not it is staged. So there's also the cache status, but then there's also Samweb tool that can do that. This one happened to not be online. I think it is right now. But at the same time, you can also do the same thing where instead of using -- file, you can use a dataset name. So in this case, Heidi was testing out a 1 GB Monte Carlo test and found that all of it was on disk and all of it was online in Dcache and none of it was nearline.
Don't do this for 50,000 files. So
no, don't do that.
I tried, not good.
Specifically to find out about pre-staging, if I go to Samweb Users Guide, oh, I've forgotten. Maybe it isn't in here. I was hoping to answer Ana Paula's question. In general, what you would do is you would use the Samweb pre-stage command with a predefined data set, and then we'll automatically track it for you. So, but I think I'm a little over time. I'm going to skip UPS. But
you should all
there are a
read
couple
this.
of exercises. Yeah, I'll leave that for you. I'll leave that as an exercise to the reader. It's a horrible thing to say. Questions? If not, should we go to the quiz?
Kind of a loaded question, but
yeah,
you talked about a lot of good functionality in SAM. How much of it is when we switch to Ruscio?
Yeah.
What functionality do we absolutely make sure we gotta have?
Okay. So in terms of switching over to Ruscio, I would say that Ruscio is serving a different purpose than SAM, right? That there is not much overlap between the two. It's not purely orthogonal because SAM does track locations, but Ruscio also tracks locations. So that part of it, I think Ruscio will be responsible for. And we want that to be within Ruscio because Ruscio also has built-in capabilities and solutions for how to make sure that if we say, I want this file to always have at least 2 copies, and those 2 copies have to be separated by an ocean. If one of the storage elements goes offline, Ruscio will check and say, hey, by the way, this one file that I had located in Spain, for whatever reason, PIC is now offline. I'm going to replicate it over to IN2P3, or I'm going to replicate it to the UK. Like that location gets tracked within Ruscio. I think that when we get new data management tools such as Metacat or the data discovery or data dispatcher, tracking of locations won't necessarily be part of those projects. But I think that within SAM, the ideas of a metadata catalog, uniqueness of files, and not necessarily the exact replication of data sets, snapshots, or projects, but some of those things go in there. The discussion of what absolutely has to be replicated, I don't think I have ready at the top of my, on the tip of my tongue, nor do I think there's enough time. It is a very good question. And basically I'm saying you've stumped me because I just can't remember everything right now.
Because this is the 3rd data handling transition I've gone through. And so one of the things that SAM does that I have not seen Ruscio do is a good job of the whole parent tree and child tree without a bunch of gymnastics.
I think Metacat does that. I think that functionality is already built into Metacat.
So there'll be sort of a Metacat equivalent command, and it'll get wherever it needs and pull it out.
Yeah, I think that's actually already exists, and it's Igor can explain it. What doesn't exist quite yet is the real-time tracking of what's going on with a project. That's what we don't have quite yet.
Yeah.
But Metacat basically already has I think the full file metadata aspect, except for locations of SAM.
Yeah. And we're relying on Ruscio to provide those locations.
Okay, I think that we're running a bit late in here, so perhaps we'll have to wrap up this. Thank you so much, Kirby, for giving
Claire.
us a tour. What?
Thank you, Claire.
Yay, Claire.
Appreciate it.
Well,
yay, Kirby.
Yeah, well, this is really a lot of work from Kirby. So I just wrote a couple of corrections for later, and so the site will be updated. Thanks so much for this. And you have still a bit of a homework, Kirby, on some of the questions on the live docs, and really feel free to correct on whatever I tried to write when you were talking. And thanks so much for participating, everyone. So I think we all deserve a break. That will be a nice, right? And for the interest of time, I decided that regarding the quizzes for data management and storage spaces, I will upload it to Indico, and you can do it on your own, and then the solution will be posted. And if you have further questions, you can sign up the Slack channel that we created for this tutorial, and it's going to survive after the event. So then you can write further questions that you have offline after when you study the material. It was really a lot of information. So, and as you can see from some experts' questions, we're continuously learning. This is science at the edge. So this is why this is not trivial. And Kirby did a wonderful job to explain all of these different tools. So let's have a break and resume in 10 minutes from now. So at the hour, so that would be easier for people in different time zone. Thanks once more, Kirby. I will update the Indico with the quiz. So if you still feel fresh after a bit of a coffee, feel free to have a look. And then we'll continue with Ken on the grid job business, and there will also be a quiz. So if you have any questions, feel free to let us know, and enjoy 10 minutes of break.